Sathyabama Institute of Science and Technology.
Hello everyone, this is Dr. Priya Shirley Muller, Assistant Professor from the Department of Mathematics, Sathyabama Institute of Science and Technology. Today we are here to see harmonic analysis in Fourier series. So before we actually go into the video, first let us see what is Fourier series. Okay, so Fourier series is basically an infinite series. Now, any function f of x defined in a general interval c comma c plus 2l can be expressed as a Fourier series if it satisfies a set of conditions. Now, these conditions are called the Dirichlet conditions. So, a function has to be single valued, well defined, it has to be periodic, it has to be piecewise continuous, it has to have finite number of maxima and minima. So, these are the conditions a function f of x should satisfy for it to satisfy the Dirichlet conditions. And only when a function f of x satisfies the Dirichlet conditions, it can be expressed as a Fourier series. Okay? Now, harmonic analysis, if you see, is a very important terminology in Fourier series. In fact, every term in the Fourier series is called a harmonic. Okay? So, before we actually get into this, we will first see the definition of harmonic analysis and then move on to problems. So, you know, the process of finding the Fourier series of a function using a set of x and y values, using a set of data is what is called the harmonic analysis. Okay, so you will be given a set of x and y values. At x equal to 0, y is 1, at x equal to 1, y is 2, something like that. So, you will be given a set of x and y values. Using this data, you can find the Fourier series, and that process is what is called the harmonic analysis. Okay, so the process of finding the Fourier series using a numerical set of data is what is called the harmonic analysis. Now, if you actually see the Fourier series, we all know for a general interval c comma c plus 2l, how do you define the Fourier series? F of x is equal to a naught by 2 plus sigma n equal to 1 to infinity a n cos n pi x by l plus b n sin n pi x by l. Now, when you expand this series, let's put n equal to 1, 2, 3 and get each term in the series. When you put n equal to 1, you get a1 cos pi x by l plus b1 sin pi x by l. And what do you get when you put n equal to 2? You get a2 cos 2 pi x by l plus b2 sin 2 pi x by l and so on. Now, you know what the first term is called? It is called the first harmonic. And what is the second term called, which has a2 and b2? It is called the second harmonic. And what do you think will be the third harmonic? The term which has a3 and b3 in it. Okay, so and so on. Now we have the Eulers constants in the Fourier series. The unknown constants in the Fourier series are called the Eulers constants. They are also called Fourier coefficients, Fourier constants. They have a lot of names. Now, to find these constants, we have formulae. Okay, so a naught is given by sigma y by n. Now, what does this n stand for? It stands for the number of observations in the given table exactly in one cycle. Once the values start repeating, we do not take them into account. Okay, the values in one cycle, the number of observations in one cycle is your n, and sigma y stands for the sum of all the y values. Similarly, we have a formula for an, and that is twice sigma y cos n pi x by l by n. Similarly, we have a formula to find the constants bn. Now, that is given by twice sigma y sin n pi x by l by n. So, the only difference between the formula for an and bn is in an you have cos and in bn you have sin. But otherwise they are exactly the same. So, as I told you earlier, n stands for the number of observations strictly in one cycle. Now, I want you to know something, that when we go on to problems, for all calculations, we always consider values strictly in one cycle. Now, we all know we are dealing with periodic functions. So, obviously, the values will start repeating from one point of time. So, values in one cycle is what we consider for calculations. This I want you to remember before we go on to problems. Now, this is just a corollary which I am sure you'll understand. Now, what we discussed is for a general interval c comma c plus 2l. Now, let's say supposing L takes the value pi for a particular problem, then the formula will become f of x equal to a naught by 2 plus sigma n equal to 1 to infinity a n cos n x plus b n sin n x, right? Because cos n pi x by l, when L is pi pi gets cancelled. You are left with cos nx and simply sin nx. And therefore, this will be your first harmonic and this will be your second harmonic. And therefore, the formula for a naught, an and bn will be reduced to, this is the same, but this will be reduced to twice sigma y cos nx by n, and this will be reduced from twice sigma y sin n pi x by L by n will be reduced to twice sigma y sin nx by n. This is because L is pi. Now, this is only when L is pi. Now, we move on to problems. We have the first problem here. So, let us read the question. It says, find the Fourier series expansion of period 2 pi for the function y equal to f of x, which is defined in 0, 2 pi by means of the following table. Find the series up to the second harmonic. So, you have a set of x and y values given. I hope you all see that. Yes. Now, you are asked to find the Fourier series for this particular data using, till the second harmonic. Alright. And one more thing that I want you to notice, this set of values is defined in what interval? 0 to 2 pi. Do you notice that? So, what is the interval now? Now, these are the things that you have to notice. Where is the function defined? What is the interval? Okay, that you have to notice. Second thing that you have to notice is till what harmonic is asked. So, you are asked till the second harmonic. Okay, so what constants should you find then? Because it is the second harmonic, A naught, A1, B1 is the first harmonic, A2, B2 is the second harmonic. So, you will have to find totally 5 constants. Okay, that will be the objective. But before that, first let us write down the interval. What is the interval? Where is it defined? 0 to 2 pi. Now, what form is 0 to 2 pi? It is of the form 0, 2L. So, obviously, what is L? See, there are 2 types. One is 0 to L, the other is minus L plus L. Okay. So, since this is of the form 0 to L, obviously, what is L here? L is pi. So, what will the Fourier series be? The formula for A naught, An and Bn are given. That will be twice sigma y by 6, twice sigma y cos nx by 6. This we have already seen, right? Okay, let us move on. A naught formula is written, A1, B1 formula is written. I hope you realize that. See, what is An formula? Twice sigma y cos nx by n, right? Now, n is 1. Put n equal to 1, you get this. Okay? Similarly, in Bn formula, put n equal to 1, you get this. And also remember, L is pi. That is why you have just sin nx and not sin n pi x by L. Okay? Similarly, write the formula for A2 and B2. Why should you write the formulae first? Because you will only then know what columns you need in the table. Okay? See, these are the things that I need to find, 5 constants. If I need to find all these, I need to know all these sigma values, right? So, now you know what columns you will need in the table. So, let us right away go ahead and form the table. So, when you look at this table, what do you understand? Obviously, what values will you need? The x and the y values. So, these x and y values, I have simply taken it down from the question. I hope it's very clear. Now, the last set of values repeated. Did you notice that? I hope you noticed in the table given in the question, the last set of values repeated. See, when x is 0, y is 1. When x is 2 pi, y is 1 again. Why is this? Because it's a periodic function. But for calculations, I already told you that you have to take only values strictly in one cycle. So, we will consider only values from 0 to 5 pi by 3 for calculations. So, where is this needed? 2 pi? Only when you find L, only in the beginning of the problem. Okay? In no other case will you need it. So, for calculations, we will strictly concentrate only values in one cycle. So, let us move ahead to the table now. Alright, so as you can see in the formula, what are the columns that you need? Tell me. Let us go to the previous slide and see what columns will you need. You will need a column for x and y because you need sigma y. Okay. Now, you also need sigma y into cos x. It is not sigma y into cos x, it is sigma of y cos x. Okay. So, you will need a column for cos x so that you can find y into cos x and sigma of that. Sigma is just the total of that column. Okay. Similarly, how will you find sigma y sin x? You need a column for sin x so that you can find y into sin x and the total of that column will give you sigma y sin x. Similarly, sin 2x and sigma y sin 2x. Similarly, cos 2x and sigma y cos 2x. Now, these are the columns that you need. So, those are the columns that you see in the screen. Okay. So, first thing that you will do is once you write the formula for A0, A1, B1, A2, B2, you will write down the columns, all the columns that you need. You will first fill that up. Okay. and then you will start filling up the values. Now, we will first write the values for x and y. As I told you earlier, that last value 2 pi is not to be written because that is completely excluded. Values in one cycle is considered, that is what we have written. Now, please remember, look at the values of x, people. You have every x value in terms of pi, so that the unit is in radians. Now, when the unit is in radians, it's very important that when you use your calculators, you change the mode to radians, because by default it will be in degrees. So you have to change the mode to radians and then begin your calculations. Alright, do not forget this. So how do you change the mode to radians? I'm sure you can manage that. Press mode twice. It will ask you for radians, you'll have to press 2 again. That is how you do it. Okay. So once you do that, you can find. Now why I'm stressing on this is because even if you don't change the mode to radians and start with the calculations, you will get beautiful values, but they will all be wrong. Okay. So this is really important. Change the mode to radians before you begin. Because the values of x are given in pi, by default it will be in degrees. Alright. Okay, so let's get back. So I've written all the cos x values. For every x, the cos x values you'll have to fill up. Then you'll have to find y into cos x. So what should you do? Basically, you have to multiply these two columns. So multiply 1 into 1, 1.4 into 0.5, 1.9 into minus 0.5. So that is what you're going to do for every set of values. Multiply y with cos x. Why? Because I need sigma y cos x for finding a1. You remember? Similarly, write down all the sine values, okay? And then for every x, write down the sin x values. Then you will multiply y with sin x. So that will give you y sin x, write down all the y sin x values and then find its total. Similarly, you will write down, do you see that I've written cos 2x values here in the end? You can form a separate column for cos 2x, that will be easier, so that you can find cos 2x and sin 2x, okay? And then find y into cos 2x and y into sin 2x. So this is how you fill up all the values and find the sum only for the columns that are needed, okay? So you need y cos x for what? You need sigma y cos x for a1. You need sigma y sin x for b1. You need sigma y cos 2x for a2, and you need sigma y sin 2x for b2. So now that we found all the values in the table, all you have to do now is substitute in the formula and write down the Fourier series till the second harmonic, okay? So let's move ahead. So this is what I've done. See, all the values from the table have been transferred here and you found a0, a1, b1 and a2, b2. Okay, just substituting in the formula and getting the values of the 5 Eulers constants is what we need. And then finally, you will substitute these in the Fourier series till the second harmonic. So that will give you the final answer. Okay, so I hope this is clear. Now let's look at another problem which is similar but slightly different. So let's see how this is different. Okay, here again you are asked to find the Fourier series till the second harmonic. Alright. Now the function is given by the following data. So you have the x values given, the f of x values given. Now what do you note when you see the question? The interval is not given. So you need to find what L is. But the most important thing is I want you to first note the data. Now it very clearly has only values exactly in one cycle, strictly in one cycle. Because you don't see the first value of f of x and the last value of f of x repeating, isn't it? Only if it repeats, we have a problem. Now here there is no repetition. So what does that mean? Values in strictly one cycle is given. So where is x defined? How do I find that? I need to find the next set of values. Do you understand? These values are only values in one cycle. If I want to find what L is, I need the next set of values. If I want to find where x is defined in. So for that, if x values are 0, 1, 2, 3, 4, 5, what will be the next value of x? Obviously 6. So the next value of x is 6. What will be the next value of f of x? The first value and the last value we know will repeat because it's a periodic function. Therefore, the last set of values will be x equal to 6 and y equal to 9. Now, why do I need these? I need these to find L and not for any other purpose. Because for calculations, anyway, I'm going to use only these values strictly in one cycle, right? So, I need the last set of x and y values only to find L. Now that I know that the last set of values is x equal to 6 and y equal to 9, where is the function defined now? It's defined from 0 to 6. So, what is the interval? 0, 6. And 0, 6 is in what form? 0 comma 2L. So what is 2L equal to? 6. So what is L? L is 3. So now I know L value is 3. So in the formula wherever I have L, I am going to replace it by 3. So first thing, what should you do? Write down all the formulas of all the Euler's constants so that you know what you have to find, right? What columns you need in the table. It's very important you do that first. So what is A0 formula? And N is again 6. I hope you noticed that. From 0 to 5 we have 6 values, okay? So N is the number of observations strictly in one cycle. Now what is A0 formula? 2 sigma y by N, okay? Similarly, what is A1 formula? See, An is twice sigma y cos n pi x by L by N. Okay, so what will A1 be? Twice sigma y cos pi x by L by 6. That 2 and 6 they've got cancelled here, and N is 1. And what is L? N is 1 for A1. What is L in general? L is 3. So wherever you have L in the formula, you have to replace it by 3. So this is the formula for A1. Similarly, what will be the formula for B1? Only thing is you have to replace cos by sine. Okay. Now what about A2 and B2? It's the same set of formula, isn't it? Same set of formulae, except that you will have 2 pi x by 3 here, isn't it? Because n is 2. Similarly, sine 2 pi x by 3. It's the same formula with n equal to 2. So now that you know, please I want you to concentrate on the ones that have been marked in yellow. So I want you to know that what columns will you need in the table now. Please note, sigma y you need. Similarly, you need sigma y cos pi x by 3. You need sigma y sin pi x by 3. You need sigma y cos 2 pi x by 3 and sigma y sin 2 pi x by 3. So these are the things that we are going to find from the table and then substitute. So as you see from the previous formula, now you know what columns you need, right? So let's fill up the columns. Now, as usual, you have the x and y values. Pi x by 3 you definitely need because the angle is pi x by 3, right? So once you find pi x by 3, you note that the angle is again in radians in terms of pi. Therefore, change the mode to radians. It's very important. By default, it will be in degree. Please do that first before you start with the calculations. Then we will find cos pi x by 3. Y into cos pi x by 3 we need for A1. Similarly, y into sin pi x by 3 we need for B1. Similarly, y into cos 2 pi x by 3 we need for A2, and y into sin pi x by 3 we need for B2. Is that okay? So find all the sum of all these columns, substitute in the formulae and get the values. Once you get the values, you simply have to substitute in the Fourier series till the second harmonic. So the general formula is what you will have. A1 cos pi x by L plus B1 sin pi x by L. L is 3, right? So substitute for A1, B1, A2, B2 and A0. That gives you the Fourier series. So we come to the end of the second problem. Now I'm going to go quickly just to the third because this problem is based on half range sine series. So it's slightly different. So let's just quickly read the question. Find the first 3 harmonics of the sine series defined in 0, pi. Okay. So it's a sine series that is asked and the interval is 0, pi. What is the standard form of any half range series problem? 0, L. Okay. So what is L here? L is pi. So L is pi. And the values of x and f of x are given. The last set of values is repeated, so we neglect them for calculations, remember that. And then because L is pi, the formula reduces to sigma. See, what is half range sine series? I hope you know the expansion. F of x is sigma n equal to 1 to infinity bn sin n pi x by L. Now the question is asked only till the third harmonic. So you will have just b1 sin x plus b2 sin 2x plus b3 sin 3x. That is all you will have. So you need to find only these 3 constants. So the formula is written because L is pi, it is reduced to just sin x, sin 2x and sin 3x. So these are the things that you have to find. Once you know that, you can go ahead and form the table, okay. Find all the values that are needed and then find the sigma values that are needed and then simply substitute in the constants b1, b2, b3 and that will give you the sine series till the third harmonic. This is again one problem where the last value is not repeated. So 0, 12 will be your interval. So 2L will be 12, so L will be 6, okay. So it's kind of similar to the second problem that we saw. So I believe that Fourier series is actually a very, very important subject, It has a lot of applications. It has umpteen number of applications. If you see that, if you want to understand certain concepts in electrical engineering, Fourier series is really essential. And if you want, I mean, circuit analysis and electronics, they all use Fourier series, the concept of Fourier series. It is used for modulation and demodulation of voices in telecommunication system. It is also used in the design of many filters in image processing, that's in signal processing. Okay, and it is also used to find the solution of heat transfer in a rod. See, there are so many uses as far as Fourier series is concerned, and harmonic analysis is one important topic here, and I believe that this was really useful for all of you. So this is thank you from Dr. Priya Shirley Muller, and thank you so much.